Hi everyone, my name is Thomas Kim. Today is May 29th, 2019. This is 24th episode about the future of C++ programming, C++ 2A standard. In this episode, we will try to create a dynamic array faster than std vector. More specifically, we'll be using if constexpr is POD, alignas, aligned memory allocate, aligned free. For more information about if constexpr, you can watch this video, Raison of constexpr, and also this video, nontype constexpr if constexpr. If you click these links, you can learn more about if constexpr. Because this session continues from my previous video, episode 23, you should probably have to watch all three videos, episode 21, Move Semantic Dynamic Array, and episode 22, 22nd, How to Integrate Iterators to Custom Class, and episode 23, How to Apply Class Invariant to our custom class design. If you haven't watched these three videos, please watch them. If you are my existing audience, then you can download our previous source code and follow this session. If you are new visitor to my YouTube channel, please visit extension talkplatform.com website and click this button to download source code, and also you have to watch this video. By watching this video, you have to make proper system environment variable settings. Otherwise, you cannot follow this episode. If you have downloaded the source code, show in folder, unzip it. If you unzip it, in tutorial folder, you can find source code for episode 21, 22, 23. You need these files to follow this episode, so please download the source code once again. Then copy this folder, copy, then paste it to your working directory. Then start Visual Studio Code. Go to File, open folder, then you can open CPP extension folder, then select folder. In my case, I will select CPP extension root folder. Under CPP extension, you can find the tutorial folder. Click this button, O24 dynamic array.cpp. Open invariant CPP. Copy all, Ctrl A, Ctrl C, paste to dynamic array CPP, then close this file. This is the previous state of our application. Before I proceed, I will help you understand what is POD, plain old data type. POD, plain old data type. POD is C-style struct or C++ primitive data type. For example, struct vector 3D POD size t mx my mz mcolor struct vector 3D not POD size t mx my mz mcolor. I will copy this struct name. If the class or struct that has destructor other than default destructor, I say if a class or struct has a custom destructor other than default destructor, provided by the compiler, then it is not a POD. So it has destructor, so this is not POD. I will add a member function here. Void set size tm, size ty, I would say x, size t, z, mx, x, my, y, mz, z. POD type can have a non-virtual member function. So this struct is still a POD type. I will copy this function, copy, paste it, but I will make it virtual. Then it is virtual function. I will create here void test POD types stream. I will copy this struct name, copy, paste, is POD. Then we can test std is POD, b, paste the type name, and there I will copy, paste, then I will copy this name here, okay, and I will copy this function name, paste it here, and I will disable it. Start your command prompt. You should be in CPP extension tutorial folder. In this folder, we will be using Microsoft Compiler CL, EHSC, STD, C++ 17, O24, dynamic array.cpp, fe, aexe, hit enter, cls. So because this function 3D not POD has destructor and also virtual function, this is not POD. Ctrl K, Ctrl C, disable destructor. Compile again. This vector 3D not POD is still not POD because it has virtual member function. Now I will enable it. Ctrl K, Ctrl U. Now I will disable it. Ctrl K, Ctrl C, and build once again. This is not still POD because this has custom destructor. I will enable it once again. Ctrl K, Ctrl U. Now I create another one. Struct. It is still not POD. I will copy this and I will create another member, std unique ptr int. This member is not POD type, it has destructor. If a class or struct has a data member that has a destructor that is not a POD, then the class or struct is also not a POD because it has a data member that is not POD type. It is not POD. I will copy once again. Copy, paste. You should not forget semicolon here. Then I copy it, paste, paste. Okay. Now let's build once again. Okay, this is false because this member is not POD. And we can also test like this. Stream integer ptr is POD. Okay, std is POD b int pointer, and there we compile once again. Pointer type is POD. Any C++ primitive type, C++ primitive type such as character, int, double pointer, etc. are POD type. We can use MEMCPY to copy one POD to another POD. Okay, so in our previous episode, when we design dynamic array, if this element type is not POD, we cannot use MEMCPY. We cannot use MEMCPY if element type is not POD. Okay, we can use MEMCPY only when the element type is POD. That's why I explained what is POD. Now I will optimize this class one by one. I will scroll down one by one and I will fix. So here we do not need to check M size. In our previous episode, I said we will use class invariant. In our class invariant, we assume M size is always greater than 0. So I remove this. Also, instead of doing this, I can simply put like this. And here, I will take another approach like this. If constexpr std is POD b element type, else I will modify like this our code. Okay, element type is POD, then we will use aligned pre. Okay, this ptr. This to use aligned pre, we have to include cstdlib. Okay. Then here we will create allocate function. Instead of doing this, we will create a function like this. I will copy it here. Void new allocate. I say ALLOC. If constexpr std is POD b element type, else here this ptr align malloc. We have to provide a size. This is byte size, so this m size times size of element type. This is byte count. We align 16 byte. Else this mptr new element type, this m size. This new can throw exception, so we have to catch like this. Try catch or I will just throw here if this mptr is null, then we throw talk platform throw debug message, debug exception, allocation failed. In this case, talk platform throw debug message, allocation failed. Here constant std fed alloc operator new throws std fed alloc if allocation fails. Okay, I hope you understand this concept. Before we call this function, existing memory should be released. This m size should be greater than 0. Otherwise, memory leaks. Otherwise, undefined behavior. I will delete this function. We will extremely optimize this class. Now let's go down. We don't need this because we have a class invariance that says size should be always greater than 0. We scroll down and we can use pointer arithmetic. We can remove this part. And also I will remove this part. And enable this and I will also remove this way. I will do this. Here I will delete this, and we will use pointer arithmetic and go down, go down, go down. Now we can modify this part like this. Cut, paste it here. Now we allocate new ALLOC. Okay, if allocation fails, it throws. If allocation fails, this function throws exception. So we don't need concern about this part. Now scroll down. I will delete this part. Also new ALLOC. Okay. If allocation fails, it throws. There is no memory leak. And scroll down. We can delete this part. New ALLOC. If allocation fails, exception is thrown. So we do not need concern about exception anymore. Here, if constexpr std is pod b element type, then we can use memory copy. Cut, paste. Otherwise, we have to copy element wise. For size ti equals 0, I less than this, m size plus I, this, mptr I, right hand side, mptr I. If element type is a pod, then we can use mem cpy. If element type is not a pod, then we have to copy element wise. I will factor out this part. Copy, copy, go to private section. This is private section. Void copy memory element type right hand side ptr paste. So I copy this and I can change like this, and here I can also change like this, or I copy this, paste, I modified like this, copy, paste, paste. I modified like this, and I will make it inline. Then copy this function, copy, scroll down, here we can change like this, copy, mptr. I factored out. I will copy this function once again, copy, scroll down, I will remove this, and here I will paste like this. Also paste like this. So we have to allocate memory here. New ALLOC, because we have to allocate memory. Then copy, so I can clean like this. I fixed and scroll down. I will remove this part and I will remove this part. Scroll down, I will remove this part. Now let's test if our code works properly. In the function main, we disable this part and we will enable this part. Now let's build. Seventy-four. I need typecast. CLS. Okay, it works perfectly. Now let's do some benchmarking. We will add a line as 16. If we are to use SSE, we need to align our data 16 bytes. So I added a line as here. I will copy it once again here too, and this is float or double. I will use float. Then I will change it like this: float, float, float. Also here I will modify into float to simulate real application. Then I will add operator, output operator like this: std or stream operator, std or stream os constant. Copy this. B OS. I will use angle bracket. B MX. B MY. B MZ. I will modify like this. Return OS. We are defining operator. I will copy it once again and paste it here. I copy it, paste it here. Okay, we defined operator. We need to include chrono random here. Include talk play fun chrono random HPP, and go down here, template type name, element type, void, benchmarking with primitive type, size t, test count, size t, element count. I created a function stream benchmarking with type talk play fun types type list element type and there stream with std vector talk play fun types type list t element type test count element count and there we define stopwatch talk play fun chrono random stopwatch SW for size ti equals 0 I less than test count plus I we define vector std vector element type b element count allocate memory at one sweep for size tj equals 0 j less than element count plus j vj element type j if element count less than 20 21 stream b and there stream elapsed SW elapsed time and there Now I will copy this part. Copied, paste, dynamic array, dynamic array. This part is the same. Now let's copy and test it. I copied and pasted it here. I will disable it. I will give 5, 10 million. 10 million elements. I have to provide a type. 10 million double. Or you can use int too. CLS. Let's try with Microsoft compiler. Sorry, I have to reset. Reset stopwatch. Now let's build once again. 494. Element type. Please note that we are using auto switch optimization switch using Microsoft compiler CLS. In case of using vector, it takes 395 milliseconds. In case of dynamic array, it takes 350 milliseconds. Dynamic array is slightly faster than std vector. Now I will copy this once again. Copy, pasted. I will say class type. I modify the class type. Then we need to modify this part. Set. It should be float. J. Float. J. Float. J. Like this. Then I will copy this. Copy. And paste. Now let's try it. I copied it. Paste. This is now class type. Then I will change it to like this. Or 1 million. And it should be vector 3D. This is POD type. I copy once again. This is class type, not POD type. And I will put it another one. I will use integer type, int type, and I will test 100 times, 10 times, or I will modify it floating point type, I will say 20. Okay, now let's do the benchmarking. We are using Microsoft compiler. CLS A, hit enter. Benchmarking with the type int. In case of vector of type int with test count 10, element count 10 million. In case of STD vector, it takes 396 milliseconds. In case of dynamic array with the same condition, it takes 370 milliseconds. In case of STD vector of type float, 10 million with 20 times, it takes 1073 milliseconds. In case of dynamic array, it takes 891 milliseconds. Dynamic array win. Dynamic array win. In case of double, dynamic array win. In case of this POD type, this is struct with 1 million 5 times. In case of STD vector, it takes 94 milliseconds. In case of dynamic array, it takes 59 milliseconds. In case of this is normal class type. In case of STD vector, it takes 224 milliseconds. In case of dynamic array, it takes 270 milliseconds. In all cases, dynamic array wins. In case of normal class, this is normal class, not POD type. STD vector and dynamic array is almost the same. Now let's try with the Clang compiler. CLS. This is Clang compiler. In case of Clang compiler, vector of type int 400 milliseconds, dynamic array 370 milliseconds. Dynamic array win. In case of float, dynamic array win. It's 900 is 700. In case of double, in case of STD vector double, 419 milliseconds. In case of dynamic array, 332 milliseconds. Dynamic array win. In case of struct type, plain old type, vector 85 milliseconds. In case of dynamic array, 63 milliseconds. Dynamic array win. In case of not POD type, STD vector takes 166 milliseconds. In case of dynamic array, 189 milliseconds. So in case of class type, vector wins, slightly wins. Let's try with the GNU compiler. CLS. We are testing with the GNU compiler. In case of GNU compiler, of vector of type int 410, dynamic array 299, almost 300, STD vector of type float 900, dynamic array 750. In case of double 395. In case of vector dynamic array 320. In case of POD type STD vector 92 milliseconds. In case of dynamic array 57 milliseconds. In case of not POD type class type STD vector takes 177 milliseconds. Dynamic array takes 175. In all cases, dynamic array wins. Why? Why dynamic array wins over STD vector? Please subscribe to my YouTube channel. Thank you for watching.